Effective system testing should not emphasize particular lines of code, but rather making sure that all the pieces work together as they're supposed to and the product actually does what the customer needs it to do. So there's a system test plan, and its metric of coverage is were all the requirements covered, not particular lines of code. Measuring coverage in particular requires making sure that every product requirement is tested. Ad hoc testing can help, but should not be the primary method because it's too easy to miss some obscure requirement that the customer is depending on to work. There can be some non-customer visible requirements that are also tested, especially non-functional requirements. For example, this might be the place where you make sure the system doesn't crash too often. And while it's difficult to measure the mean time between crashes, you might at least have a requirement saying we're going to put the system under heavy load and it has to operate for 2 weeks or 1 month without experiencing a crash. And we'll say, okay, that tells us that the crash resistance is pretty good. A thing that makes system testing much harder for embedded systems is that you need to deal with embedded system I/O. A lot of the times just putting the software in a virtual machine and letting it run against a test set up in the cloud doesn't do it because you need to actually deal with I/O problems as well. A technique commonly used to deal with this is to use a hardware abstraction layer and swap in some sort of I/O simulation to put it into a test simulator harness, but that has its limits. Eventually, you're going to have a room full of systems where you're letting them run to find the last few bugs that have to do with hardware interaction. That means embedded system testing can be expensive and time-consuming, especially if a person is required to press buttons or change environmental conditions to see how the system responds. Some extreme tests involve things like crashing the system in a physical way, which destroys the system. Those tests are expensive, they need to be carefully simulated, and you only get a few goes at them. So that's in sharp contrast to a pure software system where every time the system doesn't work, you fix the bug and you just try again with the test. While some development teams treat system testing as just a way to find bugs, that's probably not the best way to look at it. For a dependable embedded system, every bug found in system test should be a huge deal, because every escape to system testing partly means you missed this bug in all your other layers of the V, but also partly means that's a near miss. You almost shipped a bug to a customer. And the problem is, if you're finding a bunch of bugs in system test and you're only finding some of the bugs that are there, that means bugs are shipping to the customer. So generally, if you see more than a very small number, fewer than 5%, fewer than 1%, depends on your system, of bugs in system test, you can pretty much bet you're shipping important bugs out to your customer, and that's a problem. Instead, you should look at a bug found in system test as a process failure. So every time you find a bug in system test, you don't just fix the bug. You also go back and find out what's wrong with the process. That point is discussed more in the tutorial on testing. What you should be finding in system test is not a bad line of code. That should be found down in unit test. You should not be finding interface problems. That should be found in integration test. The few bugs you find should be system requirement defects that somehow made it past peer review and no one has noticed at this point. Usually they're the obscure edge cases of a bunch of requirements interacting in a way that is a bit of a surprise. Those are the only kinds of bugs you should be finding, and hopefully there aren't too many of them. It's tempting in system test when something weird happens to try again, and if it doesn't reoccur, you say, well, that's a one-off bug. There's nothing we can do about it. If you're seeing these types of bugs that just appear once in a while but are hard to reproduce, that's usually the tip of the iceberg for some process problems. For example, if you have race conditions, you're not going to see them very often in testing. And if you see even one, often that means you have race conditions all over the place and you just got lucky and happened to see one of them. So again, anytime you see a bug in system testing, you should be asking yourself why that happened. And if it's anything other than a very subtle requirements issue, probably you have a process failure and you should dig a lot deeper and be fixing more than that one bug.